Hello everyone, welcome back. So in this section, we'll talk about infinite series. We begin our discussion of infinite series with geometric series, okay? These series arise more frequently than any other infinite series, and they are used in many practical problems because they illustrate all the essential features of infinite series in general. So let's start with theorem geometric series. Let A be positive and R be real number. If absolute value of R is less than 1, then the sum from K is equal to 0 to infinity of A times R to the power of K is equal to A divided by 1 minus R. And if absolute value of R is greater than 1, then the series diverges. So the R is important to knowing if the series converges or diverges. You can see if R is less than or equal to -1, the series diverges. And also if R is greater than or equal to 1, the series diverges. So it only converges if -1 is less than R is less than 1. So let's jump and start with the first question. So we can see we have the sum. The sum from K is equal to 0 to infinity of 1.1 to the power of K. So first thing, you always need to know your R, right? So you can see the ratio of this geometric series is R is what? 1.1. And because we know absolute value of R in this case is what? Greater than or equal to 1. We just stop there. We can say the series diverges, and that's it. And B, we have the sum from K is equal to infinity from K is equal to 0 to infinity e to the power of -K. So in this case, you can see we have the ratio e to the power of -K, which can be written as what? 1 divided by e to the power of K, right? Which is same thing as 1 divided by e, everything to the power of K, right? So from this one, we can see what is our R. R is equal to 1 divided by E. And since R is 1 divided by E, by looking at the sum, what is A? A is the coefficient, right? There is no coefficient, so we can see A is what? 1. Or let me write so you can see. Let me just write the first term. A is equal to 1, because when K is 0, any number to the power of 0 is 1 except 0 itself, right? So now we can go ahead and find our sum, right? And because absolute value of R is less than 1, we can say what the series diverges in this, converge in this case, right? The series converges. And the sum will give us what? And we will write the sum k from k is equal to 0 to infinity of e to the power of negative k, which is same thing as the sum k from k is equal to 0 to infinity 1 divided by e to the power of k will be equal to a is what, 1 divided by 1 minus r is what, 1 over e. If you multiply everything by e, so the answer is what, e divided by e minus 1, which is approximately 1.582, right? And that's it. So C, if I'm doing C, the rule will not change, okay? We can see in this case, the sum from k is equal to 2 to infinity, 3 times negative 0.75 to the power of k. So if we write out the first few terms of the series, is helpful in this case. So we can see the sum from k is equal to 0 to infinity, 3 times negative 0.75 to the power of k. We start from what? So this is 2, not 0, 2. Start from 2 here. So the first term is what? K is 2. So we have 3 times negative 0.75 to the power of 2 plus 3 times negative 0.75 to the power of 3 plus 3 times negative 0.75 to the power of 4 plus, and so on, right? So you can see the first term is a, so this is my a, right? This is a times r, and this is what? A times r squared, and so on, right? So we see that the first term is what? We see the first term in this case, a is what? 3 to the power of negative 0.75 square, right? And the ratio r is what? The ratio of the series r is negative 0.75. And again, what do you think? Is the series converges or diverges? Because absolute value of r is less than 1, we said what? The series converges. And the value is what? The rule will not change. The value, which is the sum, k is equal to 2 to infinity, 3 times negative 0.75 to the power of k. The first term a is 3 times negative 0.75 squared divided by 1 minus r is what? Negative 0.75. And use your calculator, you will see this will give you 27 divided by 28. And that's it. Okay. Next, we are asked to evaluate the following series. So again, we will not change anything we have. On A, this example, we have to evaluate the following series. So I'm going to write down, evaluate mean what? Find the sum, right? We know our Sn is given to us as the sum from k is equal to 1 to infinity, cosine of 1 divided by k minus cosine of 1 divided by k plus 1. So, it's always good to write the first few terms, because from there you will know what you will have. So let's use this sum. If k is 1, right, we'll have 1 divided by 1, which is cosine of 1 minus cosine of 1/2, plus if k is 2, cosine of 1/2 minus cosine of 1/3, plus this will keep going until n, right? Cosine of 1 divided by n minus cosine of 1 divided by n plus 1. Let me write this one correct. So if you look, do you see you have negative cosines of 1/2 here? That will cancel with this cosines of 1/2, right? And the next parenthesis, negative cosines of 1/3 will cancel with, because when k is 3, this will start with cosines, and those, all of them will cancel out. And before this term right here, what do you have? We have 1 divided by cosines of n minus 1 divided by cosines of n. Do you see that? And this also will cancel out. So everything will be canceled out except what? Cosines of 1 minus, this is minus, this is supposed to be minus, not plus, right? Between them is always minus. So minus cosines of 1 divided by n plus 1. Okay? So if this is what, observe that the interior term of the sum cancelled. So because you can see this cancel, which is called our telescope. Okay? So now what will be left is this one. N is going to what? Infinity, right? N is going to infinity. So this sum, we can say the sum from k is equal to 1 to infinity, cosines of 1 divided by k minus cosines of 1 divided by k plus 1 is equal to the limit of Sn as n approaches to infinity. So now we need to find this limit, which is equal to, what is our Sn? Because This is Sn, right? Limit of cosine of 1 minus cosine of 1 divided by n plus 1 as n approaches to infinity. This limit is easy to find. If I substitute infinity, 1 divided by infinity is what? 0. Cosine of 0 is 1. So my answer will be cosine of 1 minus 1, which is approximately negative 0.46. Okay? So let's go ahead and do B. You know, because the initial value of B, if you look at the initial value of the index, start from 3, not 1, right? So this sum, the partial sum Sn involve n term that run from k is equal to 3 to k is equal to n plus 2, which is somewhat awkward, right? There is many ways to do this one. Some people will find the sum from, k is equal to, like for example, 1 to infinity, and then they will subtract k is equal to 1 to 3 from it. So that also can happen. But the nth term sums are most easily written when the initial value of the index is k is equal to 1. We reindex the original sum by using the substitution. Okay, we are going to use substitution, and let g be equal to k minus 2. Okay, which means this means when k is equal to 3 implies what? G will be 1. And when right? Any question? Do we just do substitution? So by doing this substitution, we can see now my sum of k is equal to 3, k from 3 to infinity, 1 divided by k minus 2 times k minus 1 will be the same thing as the summation of from g is equal to 1 to infinity, right? We said what? G is equal to k minus 2. So that means we'll have 1 divided by g times what? G plus 1. Because if g is equal to k minus 2, this also means what? K minus 1 also will be what? G plus 1 from the same thing, right? Because if you add 1 on both sides, same thing, okay? And then this is just by doing what? Let G be equal to K minus 2. So if I substitute, I can change back because, these are just variable. If you don't like G, you can go back to your K and just set K, sum from K is equal to 1 to infinity will be equal to 1 divided by G times G plus 1. You can see the first term of both series is the same thing. Look, the first term of, if K is 3, you will have 3 minus 2 here, which is 1. 3 minus 1 here, which is 2. 1 times 2 is 1/2, right? Look, right? And if K is 1 here, you will still have what? 1/2. You see, the first term is still the same thing. So it's not like I changed something. So the variable used as an index does not affect the value of its series. Okay? So it's permissible to return to the index K if you want. So that's why I'm going to change this one to K now. Okay? Sorry, I put K here. This was supposed to be G. So K. Can return to K. Okay? So let me write so you can see the variable used as an index does not affect the value of a series. So you can change it any time, okay? So now my Sn, using the method of partial, we are going to use partial fraction in this case, okay? My summation Sn, which is sum from K is equal to 1 to infinity, 1 divided by K times K plus 1, using partial fraction. So you would see this is same thing as the sum. Why am I using infinity? This is n, because I'm using Sn, so n K is equal to 1 to n, 1 divided by K minus 1 divided by K plus 1. Okay? So this is using partial fraction. This is what we will get. So in this case, you know, as we said, it's always important to write down your Sn. So you see, the first term will be what? K is 1, so we'll have, let me write this one small so you see exactly what is happening. 1, sorry, not 1/2, 1, because if K is 1, we'll have 1 divided by 1 minus 1/2 plus K is 2, 1/2 minus 1/3 plus if K is 4, if K is 3, 1/3 minus 1/4 plus if K is n, 1/n minus 1/n plus 1. So again, the sum telescope, right? So you can see why, because look, This and this will cancel out. This and this will cancel out. This and that will cancel out. And so it will left just it will left Sn will be what? 1 minus 1 divided by n plus 1. Right? So we know we can go ahead and find the sum. So I will just write the sum from k is equal to 1 to infinity of 1 divided by k times k plus 1 is equal to the limit of Sn as n approaches to infinity, which is equal to the limit 1 minus 1 divided by n plus 1 as n approaches to infinity, which is what? 1. That is my final answer. Right? So that means this sum will give us 1. Okay? So again, that's what you need to know so far. The telescoping series mean with geometric series we carry out the anti-evaluation process by finding a formula for the sequence. Okay, so now let's move to this theorem properties of convergent series. Suppose the sum a sub k converges to a and c is a real number. The series sum of c times ak converges, and it will be what? C times a. And suppose the sum of a sub k diverges, then the sum of c times a sub k also diverges for any real number c different from 0. Suppose the sum of a sub k converges to a and the sum of b sub k converges to b, then the series of the sum of a sub k plus or minus b sub k converges, and it will be a plus or minus b. Suppose the sum of a sub k diverges and the sum of b k converges, then the sum of a sub k plus or minus b sub k diverges, okay? If one of them diverges, then the sum will be diverges. So if m is a positive integer, then the sum from k is equal to 1 to infinity of a sub k, and the sum from k is equal to m to infinity a sub k, either both converge or both diverge. In general, whether a series converges does not depend on the infinite number of terms added to or removed from the series, right? However, the value of a convergent series does not change if non-zero terms are added or removed. Let's do these two examples. Okay. We have the sum of the sum from k is equal to 2 to infinity, 1 divided by 3 to the power of k minus 1 divided by 3 to the power of k plus 2. So as you can see, solution. We can break this one down to two summation, right? Minus 1 divided by 3 to the power of k plus 2. This is exactly the same thing as the sum of k from 2 to infinity. 1 divided by 3 to the power of k minus the sum of k. And we can see both converge, right? Both of these series converge. So converge. Right? So since both converges, so you know what? Let me change this one to 2. I'm going to change this number to 2 so to make it a little bit make sense to you, okay? Don't mind me. If it's one, it's same thing, okay? I just want you to see a difference between the two. So, so, you know, or should I let me, since I start with one, let me use just one. It's fine. I just want you to know, like, if it was 2, I will just take the 2 out here, okay? So, because both converge, again, we need the first term, right? For each of them. So if you check the sum from k is equal to 2 to infinity, what is the first term? 1 divided by 9, right? Because, and r is what? 1/3. And if you look, the sum three k plus 2. What is the first term? Again, the first term is what? A will be what? 1 divided by 3 to the power of 4, which is 1/81. And R is still what? Both have the same R, right? So now, look, my sum from k is equal to 2 to infinity of 1 divided by 3 to the power of k minus 1 divided by 3 to the power of k plus 2 will be equal to A. For the first one, A is what? 1 over 9 divided by 1 minus R, which is 1/3, minus, right? R, A is 1 over 81 divided by 1 minus 1/3. So same denominator, right? Now you have to use your calculator to simplify. So this will give me 1 over 9 times the 1 minus 1/3 will give me 2 divided by 3. So it will be times 3 divided by 2, right? You know the multiplication, the division. If you have a fraction divided by a fraction, you take the numerator, you multiply by the reciprocal of the denominator. Same thing, 1 minus 1 over 81 times 3 divided by 2. Keep simplifying and combine, like then you can combine this one. So this one would be 1 over 6 minus 1 over 54. And then once you combine, it will give you, which will give me 4 divided by 27. And that's it. Last, not the least, we are asked to find these sums. So again, you know what I can do is same thing, the sum from k is equal to 1 to infinity of 5 times 2 divided by 3 to the power of k minus 7 to the power of k minus 1 divided by 6 to the power of k is same thing as what the sum from k is equal to 1 to infinity 5 times 2 third to the power of k minus the sum from k is equal to 1 to infinity 7 to the power of k minus 1 divided by 6 to the power of k, right? So if we examine this one, we can see on this one, R is what? 2/3, right? Or let me break it down so you can see each of them. So if I take the first series, which is the sum from k is equal to 1 to infinity 5 times 2/3 to the power of k. We can see the first term is 5 times 2 to the power of 3 plus 5 times square plus, right? We can see the first term A is equal to 5, which is 10 divided by 3, and R is 2 divided by 3, right? Which is less than 1. Therefore, that's easy to conclude. The sum from k is equal to 1 to infinity of 5 times 2/3 to the power of k would just give me A divided by 1 minus R, which is 5 times 2 divided by 3 divided by 1 minus 2/3. Simplify everything. This will give me 10. But what about the second series, which is the sum 7 to the power of k minus 1 divided by 6 to the power of k, right? If we check k starting from 1 to infinity, the first term will be 1 divided by 6 plus 7 divided by 6 square, right? Plus 7 square divided by 6 cube. So we are multiplying the next term by what? 7 divided by 6. We can see R is what? 7 divided by 6, which is greater than 1. Then the sum from k is equal to 1 to infinity of 7 to the power of k minus 1 divided by 6 to the power of k diverges. From the previous property, this means what? Then the sum from k is equal to 1 to infinity 5 times 2/3 to the power of k minus 7 to the power of k minus 1 divided by 6 to the power of k diverges, right? So that's it. I will see you in the next section.